So essentially we're taking the power supply from the truck and we're powering up the RW30. In other cases we would use test switches to power up the RW30 using the test switches inside the cam. RW30 has all of the cables attached to it, makes it a little bit more efficient. I'm just straightening out the cables, then just attaching them to the cam. While the RW is powering up, I'm going to take the clipboard and start writing down and documenting the meter data. KPUB is the utility. Company number is going to be the number that's listed on the meter itself. Typically also the number that's in the exchange records or the map that we're using to identify where that meter is located at. Serial number, again, it's typically the same as what the meter number is. If the company number is different, there'll be a different digit there. In this case right here, we have the same serial number as the company number. So I will document that as the same number. Module serial number, if it had an AMI module, you might see a barcode, either Aclara, Landis+Gyr, Sensus, some other thing. We don't have anything, so I'm going to strike that. This meter is actually manufactured by GE, so it's a GE meter. The type is the KV2C. Sometimes it's not real clear. After a while you get to know which meter forms, meter types there are. This is a class, and we look for the CL, which is the class 20. We look for the form, which is the FM number. It's a 9S. Volts. With the multi-power supply, we use the lowest voltage. That's actually what we're going to be testing the meter at if we were to do a meter test. The amps is a TA value, so test amps, which is TA 2.5, so we're going to put that as 2.5. KH or K sub H, we're looking for that value, that's right there, 1.8. We don't use a register ratio, and now we're recording the KWH 28, and it flashed through there quicker than I could write it down, so 28, and then come back around here. KPUB. This is called a segment check. And then 28821. Demand reading is KW, which is 0.75. I believe that's giving there's some voltage values. So those are the items that we're going to record off of the meter. Next thing that we're going to look at is we're going to look at the CTs that are up on the pole itself. Those being enclosed like that, it will be difficult to identify what the CT ratios are. I'm going to have you look at the meter again one more time. It says multiply by 40. That is a telltale that it's a 200 to 5. So I'm going to use that initially here to say it's a 200 to 5. It's a 40 ratio. PT is 1, so the multiplier will be 40. And we'll just bracket that for right now, making sure that we validate that with our CT ratio test. At this point, we're ready to open up the cabinet. Get my gloves. start hooking up my wires. I'm going to hook these wires up to the top side. Start it with A phase. Go to B phase. Indicator on those switches right there. Open up those three. I'm going to open up my neutrals.
Hold on.
Okay. So we're going to then open up our shunts, our neutrals. Then we're going to apply our duckbills red side up. Jingle if it's a little bit difficult. Back in again. I'm going to come over and start entering data into the RW30. So first we're going to go to site info. We're going to go to edit site info, and we're going to add. And type in the meter number. Usually the company number is what we're going to use for the site name. This is a 9S meter, which is considered a 4-wire, service wires, it's a 4-wire. And I'm going to flip over to the meter, and I'm going to type in the serial number again. This is where we see the serial number here. 6565. Okay. Since this is in my way, I'm going to go over here. That's how I typically do that. 1.8 is the case of H. My test volts is going to be 120. All this information I'm taking right off of the sheet that I filled out. Form 9S. Test sequence is something that's not on the, but I hit default. And then demand multiplier is multiplier right there. And put in 40. Don't fill any of the rest of this stuff out. I'm going to go to the CT next. 205. Serial number is going to be a 1. Model number is going to be A. Class is going to be 0.3. The serial number and model number, by default, we always just use 1 and A. The class of CT, the CT's majority are always 0.3. That's what we put in by default. And then when we're doing all 3 CTs, we're going to be doing an A phase, B phase, and C phase phases to test. Our 2 tests that we're running is the burden test and the ratio test. When we run the ratio or the burden test, we're actually going to apply max burden of 0.5. In this installation, we don't have PTs or transducers, so we leave those. We don't touch those 2 tabs. If we did have PTs, we would enter in that ratio there. Same serial number, model number, class. So with that being done, we'll hit save, close. We'll go to load. From the drop-down menu, we're going to select the meter number, or the site name, I should say. Okay. Hit OK. And then exit. At this point, we're going to start doing our 2 tests here for Kerrville, which is power quality and CT testing. So we're first going to do the power quality. And this is where we're going to start documenting voltages. VA is going to be A to neutral, B to neutral, and C to neutral. E, A, B, and C. So 122. I use the whole numbers and not necessarily down to that first decimal place. I then actually jump down here to the secondary current, which it lines up right here, is A, or the I values. So IA is 1.3, 2.0,